Alright, so hello students, welcome you all once again to my YouTube channel. So today I'm back with it another super cool excellent trick to find electron withdrawing group and electron donating group. Okay, do watch the complete video because at the end of the video you will be perfect in this topic, and most of the question asked from this topic easily within seconds you can identify and you can answer. Okay, so let's start the video. Now first, to make you understand the concept, first let's take an example of electrophilic aromatic substitution. Now here, as you can see, we have a benzene and I have connected a electron withdrawing group. Now if an electrophile acts on this, then electrophilic aromatic substitution reaction takes place and this electrophile will get and attached the meta position. So it is meta directing. This is meta directing, which is electron withdrawing group. When it is acted by electrophile, it is meta directing. And what does this electron withdrawing group does? It withdraws electron. Okay, it deactivates the ring. Okay, it deactivates the electron in the ring, so it is deactivating. These are some of the major important points which we have to remember. Deactivating. Next, let us come to the electron donating group. Now when an electrophile acts on this type of model, okay, this type of setup, then what happens? The electrophile get attached at ortho and para position. Electrophile attached at ortho and para position. So this is ortho and para directing. Ortho and para directing. Now what does electron donating group does? This electron donating group increases the electron density on the benzene ring, so it is activating. That is deactivating and it is activating. Now how to find the electron withdrawing and electron donating group? See the trick. We have an benzene ring. Now remember one point, in the previous video also I have explained, the element, the atom which is directly connected to the benzene ring, we will name it as X, and the atom which is connected to X, we will name it as Y. Why? Because our convenience, we are solving with a shortcut trick, right? So for the shortcut trick we will be using this nomenclature. That's all, simple. Now here comes a shortcut trick. If Y, okay, if Y is more electronegative than X, then just identify, conclude that it is electron withdrawing group. Now if X is more electronegative than Y, then it is electron donating group. That's all. Now another important point, if X is positively charged, then also we can conclude that it is electron withdrawing group. Now let us apply this shortcut trick on some example. See here we can see what I told you, the element which is directly connected to the benzene ring, we will name it as X for our convenience. Now for the X, whatever is connected, whichever atom element is connected, we will name it as Y. Now identify among X and Y which is more electronegative. Nitrogen is more electronegative. Therefore, what is my conclusion? It is electron withdrawing group. Electron withdrawing group. That's all. Just by seeing at the sequence setup, we can answer. Okay, we can guess easily. Now let us move on to one more example, because the more example we solve, the better and the perfect we become, right? So just see, this will be your X. As I told you, whichever will be connected to benzene ring will be X, and for X, whatever will be connected, that will be your Y. Now among oxygen and carbon, which is more electronegative? Oxygen, right? So X is more electronegative. So if X is more electronegative, then Y, then which is that group? Electron donating group. That's all. Now let us move on to some more example. Okay, so here comes the example number 3. I have taken phenol. So which atom is directly connected to benzene? Okay, oxygen is directly connected, so this will be your X. And for oxygen, which is connected? Hydrogen, so this will be your Y. Now among oxygen and hydrogen, which is more electronegative? Obviously oxygen, right? So if X is more electronegative, what I concluded, if X is more electronegative than Y, then the group is electron donating group. That's all. Very simple. So simple, right? Now let us move on to the another last example. See here, for benzene, carbon is directly connected. Now this is little more complicated and most important example. Okay, now for carbon, we have two groups. Now students might get confused. This might be X, this will be X. Obviously everyone will recognize that carbon is X. Now for Y, which we have to opt, whether oxygen or CH3. See here, in CH3 again we have carbon, but we have to choose an element which is different from X. Now in X we have carbon, and in Y we can't take carbon. Therefore we will conclude that oxygen is our Y. And another important point, whichever will be having double bond, that will be having higher priority. Therefore that element we have to choose as Y. Very simple. Just remember one thing, same element can't be chosen. So double bonded oxygen atom we have chosen as Y. Now in carbon and oxygen, which is more electronegative? Y is more electronegative, oxygen is more electronegative. Therefore if Y is more electronegative, what I concluded, if Y is more electronegative than X, then the total group is electron what? Electron withdrawing group. That's all. So simple, right? So hope you will like the video. If you like the video, don't forget to hit the like button, share with all your friends, because this is the only channel on YouTube where you can find the shortcut tricks, most important shortcut tricks for your NEET and JEE from physics, chemistry, mathematics as well as biology in one channel. Okay, share with your friends, subscribe the channel. Thank you a lot.